Hello students, here we start with the fourth topic of 10th standard geometric constructions. Before we start with the exercise given in the book, we will discuss some of the basics construction which are needed for constructing the respective figures. Okay, so the very first construction that we are going to do is draw the perpendicular to a line segment AB of length 5.7 centimeter from given point P on this line segment AB. Okay. So for this, first we are going to draw the line segment AB, and on that we are going to take, with the help of the scale, we are going to draw. Okay. The length of the line segment given to us is 5.7. So 5.7 means this is 5 and after that 2 lines. Okay. So this is 5.7 I have drawn. Right. I'll name this as AB. And on this, I have to take a point P anywhere, wherever I feel. So here somewhere is point P. Okay. And from this point P, I have to draw the perpendicular bisector of it. Okay. For that, what do I need is a compass. Okay. And with this compass, what I'll be doing, I'll be drawing arc on either side of any measure. You can take small measure in your compass. Okay. Keep the pointer on P and give arc on either side of line segment AB. Okay. And after that, just increase the length of the arc and keep the pointer on the arc wherever you have drawn on AB. Okay. First arc. And draw arc above the line segment AB and below the line segment AB. Okay. After that, keep on the other arc which is drawn on line segment AB the pointer of your compass and intersect the previous arc. Okay, so you will get 2 points over here, 2 arcs over here which are intersecting each other, right? Now what we have to do, we have to join that 2 points over there, the point of intersection. So this is the point, and there above one of the point that you have to join. Now this, you have to check whether it is a perpendicular or not. For that, what you have to use? You have to use the protractor. So keep the protractor on point P and measure the length. Is it exactly 90? So our construction is correct. So this is the first basic construction that we have done. Now we'll move on to the next construction. Now to draw the perpendicular to a line PQ from point M outside the line. Okay. So here very first thing that you have to do is you have to take a line PQ. Now line I have said, so it may be of any measure. So here this is the line PQ. Okay. And somewhere here is point M. Right? From this point M, I have to draw the perpendicular to this line segment PQ. Now what I have to do is, I have to take a compass and the pointer of the compass I have to keep on point M. Right? And I have to draw an arc such that it intersects line PQ at 2 points. Okay? So you can draw this way. Drawn? Now this semicircular arc is intersecting line PQ at 2 points. Okay? So I'll keep the pointer on the first arc near P. Okay? Pointer of the compass. And I'll be drawing an arc. Okay? See what I have done? I have kept the pointer on P and I have drawn an arc. Right? Similarly, without disturbing the measure of the arc, I'll be keeping the pointer on the point where arc is intersecting near point Q. Okay? And I'll be intersecting the arc which is drawn from point P. So I'll get a point of intersection over there. That point I have to join with point M. Okay. So here this type of figure you're going to get. So this is what is the figure that you're going to get. I hope it is clear. Now we move on to the next construction. Third basic construction. Draw the perpendicular bisector to the segment LM of length 6.4 centimeter. Means I have to draw the line segment 6.4 centimeter, and to that I have to draw perpendicular bisector. So the very first thing that I have to do is I have to draw the line segment of 6.4 centimeter. So 6.4 means after 6, 4 lines. Yeah, till here. So this is my line segment LM. Okay, to this I have to draw perpendicular bisector. Means that line whichever will be intersecting line LM, it should be perpendicular also, and it should divide the line into two equal parts. For that, we have drawn the line segment LM of 6.4 centimeter. Now I'll be drawing the perpendicular bisector of it. Now the basic criteria for drawing the perpendicular bisector is you have to take more than half of line LM. So by mere observation, you can see that it is more than half of LM. I keep the pointer on M. Draw an arc on either side, means either side of line LM. Okay, then keep the pointer on L. Intersect the previous arc. Now if arc is not intersecting, just increase the length of the arc. And one more thing, don't disturb the distance between the arc, otherwise you will not get the correct construction. Okay. Now you have got two of the arcs over here. What you have to do is you have to join that. After joining, just give arrows on either side of it, because it is very important to draw arrows. Now name this point as P wherever that line is intersecting line segment LM. Okay. Now what you have to do, you have to measure the length of LP and measure the length of PM. Okay. So measure of LP first. Are you able to see that it is 3.2 centimeter, right? 3.2 centimeter. So PM will also be 3.2 centimeter. We'll just cross check. Yes, it is 3.2 centimeter. When I add this, I get 6.4, means our construction, means this is dividing the line segment into two equal parts, means it is the bisector of line segment LM. Now we have to check whether it is perpendicular or not. So for that, what I have to do? I have to measure it with the help of my protractor. Okay, so I'll be keeping the protractor on line LM, and wherever the zero is intersecting, from there I'll be measuring the angle. It is 90. From wherever I measure, it comes equal to 90 only. Okay, so the here angles of forming is 90 degree, right? So this is what is the third construction, third basic construction which is needed for geometric construction. This is what is the figure that you're going to get after completing the construction. Okay. Now we move on to the next construction, that is angle bisector. Next construction, draw angle bisector of angle PQR of measure 1 to 1 degree. Okay. For that we have to take first the ray in which QR will be the base. Okay. So I have drawn QR ray, and I'll be keeping the point protractor on point Q. So here it is. Now here on the protractor there are two scales. Whichever zero is coinciding with QR, that scale you have to take. Okay, so here I'll be taking inner scale. If I keep the pointer on R, then I'll be taking the outer scale. Okay, so here I'll be taking inner scale first. So I have kept the I have kept the protractor on point Q. Okay, and the measure of angle that I have to plot is 121. So here it is 120, and after that, one line. So it's 121. Now I'll be joining this. Please confirm whether it is 121 or you're getting something else. So yes, it is 121, right? Now what I have to do is I have to take a protract compass and keep the pointer of compass. Take small measure in your compass. Keep the pointer on Q. Intersect the two arms of an angle. Okay. After intersecting this, just increase the length of the distance between the two arms of your compass. Keep the pointer on the point where arc and QR are intersecting. Then keep the pointer on the point where the arc and PQ is intersecting without disturbing the distance between the arc. Now two points I have got, one of the arc I have got, see the point of intersection Q, and that point of intersection I'll be joining. Okay. Now to check whether my construction is correct or not, what I'll be doing, I'll be measuring the angle. So you can check it is between 60 and 60 and 61. Okay. Even if I measure this angle, it is between 60 and 61. Why? Because it is not a whole number. Construction of similar triangles. Two triangles are said to be similar if they have their three angles equal to one another and their side ratios are in proportion. So we will take one of the example. PQR and triangle XYZ are said to be similar when angle P is equal to angle X, angle Q is equal to angle Y, and angle R is equal to angle Z. With that, PQ upon XY equal to QR upon YZ is equal to XZ upon PR. Then the two triangles are said to be similar. Now we have to construct the similar triangles. We'll go with one of the example. Triangle ABC similar to triangle LMN. One more thing you have to take into consideration, that 1-1 correspondence is very important, and that you have to uh, consider when you are doing the problems. Okay. So the measure of triangle ABC is given to us. All sides are given, and we have to find the sides of triangle LMN by using the side ratio. It's not necessary that they will give you the sides only. The angle, two sides may also be given, or two base angles and side may be given. In that way, we have to construct the given triangle. So we'll go with this triangle first, these two triangles first. So LMN sides we have to calculate. We know that triangle ABC is similar to triangle LMN. It's already given over there. On basis of this, we have to find out the measure of the measure of sides of triangle LMN. Now here, these angles are equal. A is equal to L, B equal to M, and C equal to N. Okay. Now side ratio AB upon LM is equal to BC upon MN is equal to AC upon LN. Okay, that is equal to 5 upon 4. On basis of this, we will find out LM, MN and LM. So AB upon LM equal to 5 upon 4. I'll substitute the value of AB, that is 5.5 upon LM equal to 5 upon 4. LM equal to 5.5 into 4 upon 5. So LM's measure is equal to 4.4 centimeter. Then we go to the value of MN. For that, BC upon Mn equal to 5 upon 4, substituting the value of BC. So it is 6 upon Mn equal to 5 upon 4. Mn equal to 6 into 4 upon 5. So Mn is equal to 4.8. Now the next one, that is AC upon Ln, it is AC upon Ln equal to 5 upon 4. So 4.5 is the value of AC. So it is ln 4.5 upon ln equal to 5 upon 4. So ln will be equal to ln will be equal to 4 into 4.5 upon 4, that is equal to 3.6. So it is 1 it is 0 upon 5. So it is 0 0.9. 0 0.9 into 4 is 3.6. Now these two triangles we are going to plot over here. Okay, we are going to construct over here. So very first thing that we have to construct is triangle ABC. So triangle ABC, the measure of AB is given to us as 5.5 centimeter. So we will take first draw the rough figure. So you will have the rough idea what actually you have to draw. So the two triangles you just draw roughly. It is A, B, C. Now any side you can take as the base. Not necessary that this particular side only have to take. But generally we take the larger side as the base. Okay, and this is LMN. So here AB is given to us as 5.5 centimeter, BC is given to us as 6 centimeter, CA is given to us as 4.5 centimeter. We have calculated the length of MN. MN is 4.8 centimeter. Then LN is 3.6 centimeter. Then LM is 4.4 centimeter, right? So on the basis of this, we are going to draw the respective triangle. So here we start. Very first, AB we are going to draw. AB is 5.5. So 5.5 means after 5 lines somewhere here. Okay, this is my AB. Then I'll be taking the other two measures in my compass with the help of the scale. So AC is 4.5 centimeter. So 5 lines after 4. Okay. Keep the pointer on A. Draw an arc. Draw a little bigger arc. Okay. Then 6 centimeter. So with the help of my compass and scale, I'll be taking 6 centimeter in my compass. Okay. Now I'll keep the pointer on B and intersect the previous arc. Now the two arcs are intersecting at a point. That point will be C. Okay. So here the rays should intersect the arc and don't keep the open ends over there. Just give an arrow over there. Okay. So this point was my point C. This is triangle ABC. Now I'll be drawing triangle LMN. For triangle LMN, my base was MN. So my base will be LM. So LM is 4 centimeter. LM is 4.4 centimeters, sorry. So 4.4 centimeter, 4 lines after 4. So this is 4 centimeter. Then I have to take AC. So LN measure, that is 3.6 centimeter in my compass. Check on it. Is it 3.6? Yeah. So here and draw an arc. This is LM, right? So N will come over here. Now measure of MN is 4.8. So 8 lines after 4, right? I hope you can see. 8 lines after 4, I'll be keeping the pointer on M and intersecting this arc. Now I got the 2 points, point of intersection. So I'll be joining that, right? Then write all the measures. What was the length of AB? AB was 5.5 centimeter. Then AC, AC was 4.5 centimeter and BC is 6 centimeter. Similarly, length of LM is 4.4 centimeter. LN is 3.6 centimeter and MN is 4.8 centimeter. So this is what is the construction of two triangles. I'll just show you. So in this way, you will get the figure of two triangles. Okay. So these are the two similar triangles that we were supposed to draw. Now we move on to the next construction.